Alright, hello everyone, this is Mr. Courage. I'm going to walk you through our checkpoint review problems here. We had to do these checkpoints from these following lessons. And I'm going to walk you through my answer key and explain stuff, show you how to use some of the calculator work. And here we go. Problem number 1 asks you to find coterminal. Well, what coterminal means is we have an angle. Let's say this angle here. And then we have to find angles that match it up exactly. So this angle turns to here, while coterminal means we go around to the exact same spot. Or we go backwards to the same spot. So that just means we add or subtract 2 pi, or add or subtract 360 degrees if we're in radians. So what you can see here is I took this angle, subtracted 2 pi, 8/4 is 2 pi, and then I have this angle. These are in the same location. These are actually right here at pi over 4. And that's also 9 pi over 4 because I just went an extra loop. Then I subtracted another one, got a negative. Same thing here. I have this angle here, add on 2 pi, now it's positive. Same angle, subtract 2 pi, now it's negative. Same location, an extra lap, either 2 pi or 360. Number 3, convert degrees to radians. Well, most of us probably know that 60 degrees is pi over 3. Here's the work that goes into it. It's 60 times pi over 80. Now we don't write the word radians here, but maybe you should. It's going to help you. 180 degrees is pi radians. Multiply, we have 60 over 180. Now we could divide that, and we could get 60 divided by 180. And that's the decimal for 1/3, but really we're just reducing that fraction, so your calculator will do that. If you do 60 fraction 180, your calculator is going to reduce fractions for you, so get used to using this fraction button. We'll be using fractions most of the year, and here's fractions, here's improper fractions, mixed numbers, and here's fractions to decimal. So these 3 features right here are what you're going to use constantly in here. Next one again, 320 times pi. Again, write the word radian if it helps you. And we have 320 over 180. And again, 320 divided by 180 is a decimal. It's not going to work. And if I throw pi in there, if I throw 320 times pi times 180, that's an estimation, right? That's 5 radians. We don't want an estimation. We want something exact. So we take 320 fraction 180, and it reduces it to 1 7/9 right here, but we really don't write it as 1 7/9, so I'm going to use this feature right here that switches it from a mixed number to an improper. Second fraction button, and then now you can see it's going to take it from a mixed number to an improper, and there's how we get 16/9. And then just put the pi back in. Degrees, well, pi radians. Pi radians is 180. These will divide out, divide it 300. Same thing here. 5 pi radians. Pi radians is 180 degrees. These will cancel out, and the math is 300. And the math on there is just 5 times 180 divided by 3. And we're good because we have an exact answer. The next one asks you to find an arc length. So we have a circle, and we want an arc of 160 degrees, so somewhere over here. So we're just looking for this arc length here. Well, the whole circle is 2 pi r. So there's my 2 pi r, and I'm going to multiply by this degrees. And the degrees is 160 out of 360. Well, it has pi in there, so let's do it without the pi. 2 times 27 times 160 divided by 360 is 24 pi. This is an exact answer. Most of the time in class we'll be going for exact answers. Now if you do 25 and you multiply it by pi, now we have an estimated answer. But get in the habit of doing both. If you're unsure, do both. If you have no directions, try to go for this exact. I mean, this is the one that's meaningful. We tend not to round very much, so try to avoid rounding. Leave it here. All right, number 8 says, here's a circle. Find the area of the sector by 80 degrees. Well, there's 80 degrees. And there's my sector right there, if I shade this in. All right, well, pi r squared times 80 over 360. And again, do the math without pi in there. So there's the math without pi. 35. Well, we're not going to write decimals, so we're going to change it to a fraction to decimal. Now it's a fraction, and let's put it as an improper fraction. And there's my fraction. 3,200 pi over 9. This is the answer we're looking for. Now if you want to estimate that, times it by pi, and we'll have an estimated. But that's not what we're looking for. We're looking for the exact. And if you want to find the estimated, just do it with pi from the beginning. There you go. All right, lesson number 1-2 gives you an angle. Find the trig functions. Well, the angle is pi over 2, which is 90 degrees. Draw this angle, write the point, and remember this is our values are cosine, sine. So the sine value is 1, the cosine value is 0. Tangent is, remember, tangent is sine over cosine. So 1 divided by 0 is undefined. Now, how do you switch over here? Well, you just take the reciprocal, but they don't have fractions, so I just make them all fractions. And this one's 0, 1 over 0, so I just make them. This is 1 over 1 flipped over as 1. This is 0 over 1 flipped over is 1 over 0. And if you ever forget, just type that in your calculator. 1 divided by 0. That's an error. That's undefined. 0 divided by 1. Whoops. 0 divided by 1. 0 divided by 1. That's good. Undefined flipped over, well, that's 1 over 0, so reverse it, 0 over 1. Part B, t of 0, that's that angle there. Remember the letters are C, S, I. Cosine, sine, tangent, put them over 1, flip them over, you have undefined 1, undefined. T of negative 5, 6, well that's right there, and that's on the unit circle. So it's that triangle, it's the smaller triangle. So the sine value is 1/2, here for tangent. Flip them over. When you flip this one over, you have to rationalize it. So when you flip this over, you're going to have 2 over root 3. Multiply it by root 3, and you will have 2 root 3 over 3 here, but make sure it's negative. And flip this one over here. And one thing to always remember is our saying that all students take calculus. In this quadrant right here, only tangent should be positive. Well, yeah, only tangent's positive. And cotangent, because they're related, everything else is negative. Down here again, quadrant 3, only tangent's positive. Tangent's positive. The angle for this one put us right here, which made it a point on the unit circle, -2, negative root 2 over root 2. There's your sine, cosine, tangent, and reverse those here. All right, problem number 2. I should have wrote down the angle here. Always try to write down the angle. The angle's -3 pi over 4. Number 2, it asks you to find the trig value using the period of cosine. Well, what the period means is if I have 9 pi over 2, I have 9/2, which is 4.5, which means I go around it 2 times, and we're here. So the cosine is 0. On number 2 here, we have the sine of -7 pi over 3, puts us all the way down here, and the sine value is this height, -√3 over 2. And last one, we have not done this one in class, so I just want to point out one thing here, that if you have the cosine of a negative angle, or the opposite of an angle, and you do the cosine of a positive angle, or the angle itself, those values are the same. Just like here, the cosine of 20 and -20, both of them have the same cosine value. So whether you go up or down, that cosine doesn't change, so they're just the same there. All right, on the back, number 3 says use a calculator. So I do this, and I put my calculator in radians, and I go sine 5 pi over 7 here. And there's no directions for rounding, so we follow the directions in the book I did, and it says 782 for the rounding there. 3 decimals is fine. Cosecant of 2. Well, I don't have a cosecant button, but I do have sine, and I know the reciprocals, so I'm in radians. 1 divided by sine of 2. 1.09. All right, lesson 1.3, going on to some trig functions here. Well, they give us a triangle, and the first thing we have to do is determine what that is, Pythagorean theorem. You get root 12, simplify root 12. Root 12 is really 4 times root 3, which is 2 root 3. And then now you can pick apart the sine values. Well, this is opposite over adjacent, opposite over hypotenuse, which is 1/2. This is cosine is this one over this one, which would be root 3 over 2. Tangent is opposite over adjacent, which simplifies down to here. Take the reciprocals and you have here. And what you should notice here is this is a special triangle, right? Well, what is the degrees of theta? Well, theta must be 30 degrees. We can work backwards, and we know this trig function because it's on the unit circle. So going back gives us an angle of 30. Number 4, use a calculator to do this. Again, I don't have a cosecant button, so I use the sine function as a reciprocal. 34 degrees. Plus 30 minutes is written like this, plus 36 is written like this, and this calculator makes it nice so you can do it all in one step. Put everything in there in one step. Whoops, what did I do wrong here? I'm in radians. I need to be in degrees. Go over to degrees. Function's still there, 10.765. Number 8, there is a flag with an angle of elevation of 64.6 degrees. 19 here. What is the height? Well, that is a tangent ratio of this. Tangent is opposite over hypotenuse. Multiply this over, and I have 19. Let's talk about exact answers for a second. If this problem asks for an exact answer, you would have to circle this whole expression right there. That is the exact. If you estimate that, 19 times tangent of 64.6, there's where you get the estimation. But that's only an estimation. That's the exact answer. All right, on the number 9, cosine here gives you a triangle, 3 and 6. There's theta. Well, cosine of theta is 3, 6. If you want to go backwards, you take the inverse cosine of both sides. Gone. Inverse cosine 1/2. Let's see what that is in degrees. Inverse cosine of 1/2. It's 60 degrees. And when you start seeing these numbers that are on the unit circle, you'll start getting angles that are on the unit circle. Number 10 shows you the diagram, asks you to find A and C. Well, the tangent of 11.5 is opposite over adjacent. Do the math, multiply this over, divide this under, and we have 3.5 divided by this. Again, this is an exact answer, but if we estimate it, we're down here. Now, when you go to do this, we've figured out this is 17.2. To find C, we could use Pythagorean theorem, right? We could say 3.5 squared plus 17.2 squared is equal to C squared, but we're not going to want to do this because this is an estimation, and we don't want to use estimations in our work. We estimate final answers, not in our work. So don't do this here. Just reset up another trig function, and you get to the answer. Lesson 1.4, number 1, gives you a triangle, and it tells you the point, and the point is -2, 3. So then now you can come up here and find your sine, cosine, tangent. Well, you'd need first to do Pythagorean theorem to find out that's root 13, because we're no longer on a unit circle. the coordinates of this point, which are -2, 3, is not a unit circle, so that's not 1. All right, do the math with root 13 in there. Just make sure you have the positives and negatives right. And again, what quadrant are we in? All students take calculus. Sine is the only one positive. Positive, negative, negative. Number 2, same deal. They tell us that sine is 4/5. Well, it could have been this triangle here, right? It could have been 4/5 there, opposite over hypotenuse. But they tell us tangent's negative. Tangent's negative in these two quadrants, so it has to be this triangle. Draw it, Pythagorean theorem. That's a Pythagorean triple. The legs are 3 and 4. Hypotenuse is 5. Don't forget that one's negative. Number 3 gives us this quadrantal. It's the word they use, a special angle, which is straight down, and 3/2 puts us there. Cosine, sine, you can find everything that you need. Now you can't do cotangent. We don't have a saying for cotangent here, but if tangent is sine over cosine, then cotangent must be cosine over sine. So we just take 0 divided by -1. All right, number 4 is all about reference angles, and it's just kind of a little vocabulary topic we got to do. We draw this angle 213 degrees, which puts us there. And reference angle means the distance that it takes you to get back to the x-axis. The shortest distance back. Like I don't want to go all the way around this way. I just want to go real quick back to there. And if I'm at 213 and I want to go back to 180, well, 213 minus 180, it's going to take me 33 degrees to get back there. And if I have 14 pi over 9, well, that's going to put me way over here at 280 degrees. And if I'm at 280 degrees, 360 minus 280, it's going to take me 80 degrees to get back there. Or another way to look at it is this angle right here is 18 pi over, well, let's leave it like this. Let's just do this one here. So it just going back that way. How much do we need to get back that way? And number C, or letter C, we have this angle right here, which is 4 pi over 5. And we want to go down to this x-axis. So how many degrees do we have left to go back down here? Well, if this is 4 pi over 5, if I want to get to a full pi, I need 1/5 pi. So it's just pi over 5, because that's the distance that's left for me to get there. And the last one. Let's talk about this one again for a second here. This angle right here is 2 pi, or 18 pi over 9, right? Because 18 divided by 9 is 2. So I'm already at 14 pi over 9. So how many more do I have to add on to go from 14 up to 18? Well, that's 4 more, 4 pi over 9. I did it with degrees, and you can switch back and forth if that makes it easier. Or you can just do it in radians and say, I'm at 14 pi over 9, and I have to get up to 18. So I need 4 more. And here I'm at 4 pi over 5, and I have to get down here. Well, what do I need? I just need another 1 pi over 5. So reference angles are the degrees needed to get back to this x-axis. This is one way to think about it. All right, number 7, last one, just some calculator stuff. Degrees, tangent, 119 here. Cosecant, don't have a cosecant button, but I do have sine, 1 divided by sine of 5. Whoops, radians, forgot degrees, put it in radians. There we go. And the last one, cosine, still in radians, cosine divided by pi over 5. All right, I hope this helps with checkpoints. If you have questions, see me in class.